Hi everyone, this is Dr. Ramandeep Kaur. Welcome to my channel Adept to Teach. I'd be covering the following topics under software testing. Please subscribe my channel to receive the updates and click on the bell button for notifications. If you like the video, then consider commenting and sharing.
As up till now, whatever techniques we have taken so far, that is equivalence class testing or boundary value analysis testing, they were based on single fault assumption theory, focusing on that at any point of time, only one input can have a problem. There can be fault only in one input, and rest of the inputs were kept on nominal value. That means at any point of time we could identify the errors only in one input condition. But this is not the case in real life scenario. So you may have multiple conditions, may have multiple faults in multiple inputs at a time. So in order to study that, we are using cause effective graphing technique. So it says when we combine a number of inputs together, we get different patterns of outputs, different situations, which identify sometimes the lacunas in the software and sometimes the strength of the software. So what is cause effective graphing technique? It says whenever you are working on the dynamic test cases, you are taking input from the user, you're performing some work and you're giving output. So in order to take dynamic inputs and then work on that, identify the problems that may arise and make test cases accordingly. So we use the cause effective graphing technique. This is a type of black box testing, functional testing. That means we are concerned about inputs and outputs and we are not concerned about the inner structure of the particular software. Now there's an example I've written here. That is, let's say while using an email account, when you're entering a valid email, then the system accepts whatever you enter as a valid thing. If it is a valid email, then it will let you enter into the system. And if it is an invalid email, it will throw an error message that this particular email ID does not exist or wrong email ID. So whenever we take this type of cases, we are identifying what may be the different conditions, what may be the different actions or outputs. So we can relate this cause effective graphic technique to the conditions that we were taking in decision table, like we call it as the condition stub, and the entries in the condition table were condition stub or condition entries. Likewise, in cause effective graphic technique, whatever conditions we are taking, we call it as causes. Whatever output can come up, we call them as action entries. Those actions we refer to in cause effective graphing technique as effects. So we have conditions and actions, or we have causes and their respective effects. So this technique tends to point out different ambiguities and different incompleteness in specifications if some requirements are missed or some requirements are not written properly. There are ambiguity in what the user has said or what the customer demanded and what the software developer understood and has implied in the software. So how does this cause effective graphing technique works? It restates the entire requirements as in the form of a logical relation between inputs and outputs. So all the requirements are converted into inputs and respective outputs. So we make a Boolean graph in the form of relationships between conditions and their outputs, or inputs and their outputs, and that Boolean graph is known as a cause effective graph. We can use this technique also to convert our test cases into decision table entries also. So whatever cause effective graph we will make, we can make we can convert that graph into decision table, and when we read the decision table, every column, that means the vertical entry of every column, relates to a particular rule, and we can make a specific test case for that particular rule. Now, how do we create a cause effective graphing technique? Now, first is study the requirements, then identify what are the causes, that means what are the conditions, and what are the actions or whatever are the outputs. Then number all the causes and effects. That means if there are 4 causes, number them C1, C2, C3, C4. If there are, let's say, 7 effects or outputs, number them E1 to E7. Then it's a better practice to draw all the causes on left hand side and draw all the effects on right hand side. Now, what is the cause? Whatever different input condition we have, we call it as a cause. And whatever different output condition we get, that is called an effect. Now, when you have identified the causes and effects, then you have to make a logical relation between cause and effect in the form of graph. And those causes and effect will be connected via edges. So you can add extra nodes in order to simplify the graph or to make some relations. We can simplify the graph using some connector nodes in between. Now there are some cases, some relationships that we will see how we will use to make a cause effect graph. Now this cause effect graph is based on basically 3 things: and, or, nor. 3 operations it is the entire cause effective graph is based on. So the first condition is if A then B. So that means if A implies, then only it will relate to B. If A exists, then it will relate to B. Second is if A or B, then C. That means now we are talking about or. So if either of the two conditions exist, then the output will be C. Third type of method that will be used to connect causes and effects would be if not A or B, then C. See, on the left hand side, I am writing the causes and right hand side are the effects. So let's say A and B are the conditions. That means if both the either of the conditions should exist, we say that if none of the condition exists, we are making it as nor. So then C. Likewise, in the previous case, I said if A or B, if either of the condition exists, then we will get an output C. Likewise, we can have AND operator. So if A and B, both the condition exist, then we will have an output C. Then again, we can reverse AND also. So if not A and B, then we can reach to the condition C. And last, a simple negation, that is not. So in all, we see basic 3 operators: and, or, and not. Using these 3, we can make a combination of different representation how we can put causes and effects in the graph. Now I am taking a very simple example first. The character in column 1 should be either A or B, and in column 2 should be a digit. Now what are we doing? This example says uh, based on whatever the user is entering, we are going to update the status of the file. Now updates is made on the 2 criteria. There are 2 columns in a file, column A and column B. So now we have a condition that what do we have in column 1 and what do we have in column 2. So based on their conditions, we will decide whether we have to update the file or not, or update the message and display it on the screen or not. So that is the entire condition. So it says that in column 1, either A should be there or B should be there. So either of the characters should be there, either it should be A or it should be B. In column 2, there should be digit. So the condition we can imagine like something like this. Let's say I have a table. In this table, I have 2 parts. First column is column 1, second is column 2. So the condition says either this should have A or it should have B. So either of the characters should be there. Either A should be there in column 1 or B should be there in column 1. And in the next column, there should be a digit. So digit means from 0 to 9, any combination. So this is the condition. If this condition is satisfied, then this file will be updated and a message will be displayed that the file has been updated. If any of the condition is false, then it will not be done. Now this has given us a clue that we have to have some conditions like when character A is there in column 1, or when character B is there in column 1, or when a digit is there in column 2, or when there is no digit or no character. So based on this thought process, based on the statement, we will make a cause effective graph. Now let's read the case again. The character in column 1 should be either A or B, and in column 2 should be a digit. If both columns contain appropriate values, then update is made. If the input of column 1 is incorrect, that means there is neither A nor B, then X message will be displayed, or let's say no message will be displayed, or X message will be displayed. If input in column 2 is incorrect, then that is, it is not a digit, then Y message will be displayed. So I have made 3 causes. First cause, character in column 1 is A. Second, character in column 1 is B. Third, character in column 2 is a digit. So I have written both the conditions of column 1 and one condition of column 2. So if I negate them, then I get a condition that these in column 1, A and B is not there. I can negate C1 and C2. Likewise, if I have to check that, if I have to tell the system that in column 2 there is no digit, then I can again negate C3. And if I have to say that all the 3 conditions are true, that means either C1 or C2, out of C1, C2 only one will be true and C3 should be true, then the file will be updated. So I have made the effects like this. E1 update made. When will this update be made? When either C1 or C2 is correct. That means either we have A in column 1 or we have B in column 1 and we have C3. I'm intentionally putting this operator here so it will become easy for me to make the graph. So I have written here either C1 or C2 in column 1 should be there. That means from here causes. If either C1 cause will be true or C2 cause will be true. So C1 or C2, one condition from here will be true. And if C3 is true, C3 is, that means character in second column is digit. So I have put a operator and C3. If this particular if this condition holds, then update error message is made. So I have tried to write within the brackets that whatever are the possible conditions based on which this update will be made or this effect will be held. Likewise, when will we display uh, message X? So E2 is display message X. So in bracket, I have written when should it be displayed based on the above causes. It says when not in C and not in B. That means negation of A, negation of B. That means there is no character in column 1. So not C1 and not of C2. So now from here we can understand that this C1 condition will be negated and this C2 condition will be negated. When together both the condition are false, then message X will be displayed. Now when will message Y be displayed? When there is no character in no digit in column 2. So C3 should be false. When C3 is false, then we will get E3 message. Now, after making these causes and effects, I have simultaneously numbered them down. So C1, C2, 3, C3, E1, E2, E3. I have numbered them down. Now I will convert them into a graph. So on left hand side, I will mark all the causes, and on right hand side, I will mark all the effects. Now C1 means when in column 1 you have A, C2 means when in column B you have B, C3 means when in column 2 you have a digit. So I have marked all the conditions or causes here. Towards right hand side, I have marked all these effects. Now we have to make this condition. I have already simplified the case by writing conditions here. Based on these conditions, I have to mark it. So let's study the first condition. When we will get the effect 1, when we will get effect 1. Even says this update will be made when either from C2 or C3. One condition should be true. That means I have made 2 lines from C1 and C2. Here I have marked OR operator. This is for and this is for OR. You can, instead of this, if you want to write OR you want to write and, you can do that also. If the operator seems confusing to you, so you can use and OR instead. So either of the true conditions should be true. That is the first part of E1. The second part says and C3 condition should be true. That means this C3 should be mandatory true. So C is is true, and out of C1 and C2 one condition is true. So here I have marked one condition from here will be true. Either it will be C1 or C2, and whatever output I will get from C1 or C2, whatever, either it is C1 or I will get C2, whatever output, whatever condition is true from here, along with a mandatory condition C3, I have put an AND condition here. That means एक कैरेक्टर A तो होगा और उसके साथ एक डिजिट होगा, मान लो 0, या फिर B होगा कैरेक्टर आपका, या कोई और डिजिट 0 या 1 या कोई भी डिजिट हो सकता है. तो इस तरह की कंडीशन को हमने मार्क कर दिया E1 के अंदर. So that is my first effect when this first effect has come up. Let's see the second effect. Now second effect says display message X. When should this message be displayed? When you do not have A and you do not have B. That means C1 is also false and C2 is also false. So how can I display that? I will negate it. Now here you see that I have put a different node, add-on node here, so that I can get an output from here. So I have taken an additional node. I will number this node because this is an intermediary node only for simplifying my graph. Else what I should have done that from C2 again I will take another arrow, from C1 again I will take an arrow, from C2 again I will take an arrow, again I will put OR condition, then I will negate it. So I had to do this. So rather than making this diagram complicated, it will be repeated. Making this complicated, it is use a connector, give inputs there, whatever output you get. If you want, now here I can have multiple outputs. Same output I can negate it, same output I can use for another effect, same output I can use for another effect. That is why we use this connector here. Now, next condition, this E2 says C1 and C2 both will be false. Now here the output was that either will be true or says either C1 will be true or C2 will be true. If I negate this, that means nothing will be true. Neither C1 will be there nor C2 will be there. So I have negated it. None of the condition will be true. When none of the condition will be true, along with, then I will say the output is E2. So simply from here, I have redirected it. Else, I should have done it like this. This is the second way of making it, but this will unnecessarily complicate my diagram. So this is not required. We have to simplify it as much as possible. Third case, displays message Y. When should the message Y be displayed? When in second column we do not have a digit. That means negation of C3. So simply negation of C3. Now this diagram can be converted into a decision table like this. So I can mark all the entries of condition, all the entries of my output. Then I have, rather than writing true false here, I have marked it as my conditions, test case condition. So test case 1, test case 2, test case 3, test case 4, test case 5. When you will make this diagram, how you made it? True, false, then again divided into true, false, again divided into true, false. If I increase the lines up till here, I can call it as either rule or a test case, because we make a rule in vertical fashion. So this is how we read a rule. So we always read it in a vertical fashion or in a column way. So this becomes my one rule. So you can see from here, if condition C1 is true, C2 is false, C3 is true, then we said each E1 can be true. Likewise, if C1 is false, C2 is true, C3 is false, again update will be made. So E1 was update. So if neither of the condition was true from here, then it was message E2 displayed. Likewise, in this case, if C3 is true, rest are false, then a message has to be displayed. This is how we are going to make a test case. We are going to make a decision table. Then we will read it in a vertical fashion, and one column will be written like this. So this is a descriptive manner of how we write the test cases. So the decision table is now converted into a descriptive manner, wherein let's say the first test case says file update scenario. Validate that system updates the file when first character is A and second character is a digit. So what are the steps for that? Open the application, enter first character as A, enter second character as digit, and file is updated. This is how the every test case would be represented in a written fashion. So this type of test case, whether the result is as per the expectation or not, it will be written in the last. One more column would be added, actual result. So this is how we convert your conditions to cause effective graph. Then we convert it into a decision table, and after that we convert it into a test case scenario. Now I'm taking a bit complicated example. So we'll convert the triangle problem into cause effect graphing technique. For your reference, I have written what was a triangle problem. We had XYZ three sides, wherein we have to test the first condition that uh, sum of any two sides should be greater than the third side, or I can write in the reverse manner that one side should be less than sum of the other two sides. Likewise, again another y side should be less than x plus z, and z side should be less than x plus y. So if all the three conditions hold true, then the triangle will exist. If any of the conditions stands false, then we will say it is not a triangle. Next condition that we have is x is equal to y, then x is equal to z, and y equal to side z. So these are my 6 conditions. Likewise, I have some outputs. Output can be not a triangle, scaling, isosceles, and impossible condition. The last is impossible condition. So I'll have 5 outputs. So I have 6 conditions and 5 outputs. Now I'm going to convert these into my cause effective graph. I have numbered them down from C1 to C6, from E1 to E5. This is the last option, E5, which says impossible condition. So let's say how I'm making it. First, I'll make all the conditions or causes on one side, effects on second side. Now, first says not a triangle condition. I have not marked in a serial order fashion because when I'm making it, then it's a bit, it becomes a bit overlapping and complicated. So just to ease it off, I have shifted E3 above, E3 and E4, and E2 below. So first, effect is not a triangle. When this effect is going to come? When C1, C2, C3, all the three conditions will be false, then it will be not a triangle. So first we will have the true side of this condition, then we will negate it, and then it will be my E1 condition. So I have all the three conditions, and if all the three conditions are false, then whatever is my output, I will negate it. Sorry. If I am basically negating it, so it should be AND condition. So C1, C2, C3. All the three conditions are false, then I will have an output that is E1. Second condition, I'm taking third condition, that is isosceles condition. Isosceles says will be C4, C5, and C6. So if x is equal to y, or x is equal to z, or y is equal to z, if any of the three conditions hold true, then we say it is an isosceles triangle. So it should be an or. Either this should be true, or this should be true, or this should be true. So I've taken all the three conditions along with the first output of the first condition also, because this first part should hold true. If it is false, then my triangle will not exist. So initially this is an input. So from this I have taken output, that means C3, C2, C1, C2, C3, any one condition will be true, and it will be joined with this. So C4, C5, C6 are my three separate conditions. Either x is equal to y, or x is equal to z, or y is equal to z. From any of these three conditions, one condition will be true, so I put an or, and this will be joined by the previous condition, that is the triangle condition should be satisfied. If both the conditions are true, then we have isosceles triangle. Just remember how we made the decision table. Decision table says if the triangle does not exist, then you will not check for any other condition. But if you check to the true side of triangle problem, then you will every time check the triangle should exist, and then whether the sides are equal or not. So this triangle condition has to be checked in all the cases. Let's look at the next condition, that is equilateral triangle. Equilateral triangle says all the sides should be equal, which means now C3, C4, C5, C6. they should be true. All the three conditions should be true. So x should be equal to y, x should be equal to z, and y should be equal to z. When all these three conditions are true and the triangle also exists, then we will say it is an equilateral triangle. So again, I have marked it here like C4, C5, and C6. All the three conditions should be true. So I have marked an and in between. That means all the three will hold true simultaneously. So once they are true, along with the original condition of triangle problem, I have marked it as E4. So E4 is true. That means it is an equilateral triangle. Next condition is scalene. Scalene means since in equilateral says all the sides should be equal, that means all the three conditions C4, C5, C6 will be true. Now equilateral, this scalene says all the sides should be different. That means now we have to negate individually C4, C5 and C6. So I am negating all them individually. Now if I take arrows from here and then negate it and then feed it, then it will make my diagram a bit complicated. So what I have done, I have made the similar set here again. So I have made a similar set here. C4 corresponds to C4. The similar set is repeated here. I have taken the output of C4, negated it and fed it. C5, negated it. C6, negated it. When all the three are false, so I have made it and. That means C4 is false, C5 is false, and C6 is false. All three are false together. So an and condition, and there is a triangle problem that holds true. Then we will have a scaling condition. We will have output as scaling. Now comes your impossible condition. So what is the impossible condition? Whenever, let's say, we have three sides, and whenever the question says two sides are equal, three is not equal. So this is an impossible condition. That means x is equal to y, x is equal to z, but x is not equal to z. Y is not equal to. If this type of problem arises, then we call it as an impossible condition. So I can have three combinations of it. जो रिवर्स कॉम्बिनेशन है, यहाँ पे मेरे पास x और y भी हो सकता है, x और z भी हो सकता है, y और z भी हो सकता है. तो मेरे पास तीन तरह के ऐसे कॉम्बिनेशंस हैं जिनको मुझे अभी चेक करना होगा कॉज इफेक्टिव ग्राफिंग में. तो मैं एक एक करके सबको डिस्प्ले कर रही हूँ. नाउ आई एम यूजिंग डिफरेंट कलर्स टू आइडेंटिफाई व्हाट आई एम टेस्टिंग राइट नाउ. सो फर्स्ट कंडीशन चेक करते हैं. ओके, फर्स्ट कंडीशन मैं क्या कर रही हूँ, C4 को ट्रू कर रही हूँ, C5 को नेगेट कर रही हूँ, C6 को ट्रू कर रही हूँ. C4 को ट्रू कर रही हूँ, C5 को फॉल्स कर रही हूँ. दैट मीन्स x इज नॉट इक्वल टू z वाली कंडीशन ले रही हूँ मैं. x इज इक्वल टू y, y इज इक्वल टू z ले रही हूँ, एंड x इज नॉट इक्वल टू z ले रही हूँ. That means my impossible condition, and simultaneously my triangle problem should also be there. तो मैंने तीनों लिया, तीनों को join किया, and gate लगाया कि तीनों conditions मेरी true हो, तीनों conditions hold कर रही हैं same time पे, and I have given the output as E5, that is impossible condition. That is one case. Likewise, एक बार C4 false होगा, एक बार C6 false होगा, एक बार C4 false लिया मैंने, तो C4 मैंने false कर दिया, यहाँ पे negate कर दिया. C5 true है, C6 true है. तीनों के ऊपर मैंने and condition लगा दी. Apart from that, मैंने triangle condition के साथ भी and लगा दिया. Now I have fed this output to here. So that means अगर मेरी एक condition false है, बाकी दोनों conditions true हैं, और मेरी triangle भी exist कर रहा है, then output will be E5, that is impossible. Last condition. Now I will negate C6. This orange color negation is of C6. So C6 negation, C5 original, C4 original. Again I will AND them. Then the first output from here, the second output from the triangle problem. Again I will AND both of them, and it will reach to E5, that is my impossible condition. So this is how we are going to convert the triangle problem, and we have to have all the combinations which should be there. Now by visualizing these set of combinations, we will convert it into a decision table like this, and we will make a test case in this column wise fashion.